Alright, in the last video we have talked about different types of arrays, and we have learned that there are one-dimensional arrays, two-dimensional arrays, three-dimensional arrays, and there are n-dimensional arrays. Now in this video, let's see how these type of arrays are represented in memory. So are they represented as shown in the previous lecture, or they are different? So let's look at this. So let's start with the one-dimensional array. So let's say we have an array initialized like this, which consists of 9 elements. Now let's see how this is stored in RAM. So let's say this is our RAM, which is random access memory. So when we initialize an array of 9 elements, the compiler allocates 9 contiguous cells in the memory like this. So it can start any collection of RAM based on the system load and compiler decides. As the developer, we cannot do anything about this, because it's up to the system from which location the array will start. It can start from here, it can start from here, or it can start from here. But the system guarantees that all other cells will be contiguously in the memory, which means that they will locate next to each other. For example, it's not possible that we can put the first element over here and the second over here and third over here. If the system puts first element over here, the rest elements will be located next to each other. So this means that the array elements will be located contiguously in the memory. Now you might be interested why they must be located next to each other. So this is the nature of array. If you look at our definition of array, it says that the elements of array are located contiguously. And this is increase the performance of the accessing elements in the arrays. So the representation of one-dimensional array in memory is very simple. Basically, compiler allocates from any given cell, then allocates 10 contiguous cells for this one-dimensional array over here. Now let's see how two-dimensional array represented in the memory. So let's say we have a two-dimensional array like this, in which we have 3 columns and 3 rows. So the question is it going to be represented like this, or it's going to be different? Now the answer is it's not going to represent like this. The two-dimensional array will be represented in the memory as one-dimensional array. The system first locates the first row, then the second row, then the third row. So as you can see, first row is located over here, then the second row is located over here, then the third row is located over here. Basically here also in the memory the elements are located contiguously, but here they are located in the form of one-dimensional array, because all of them will be located in one row. So this means that it's not stored in the memory like this, we show over here. Now you might be interested why we are showing two-dimensional array like this. So this is for explanation for users to have a clear picture of it. So on physical level, it's stored as one-dimensional array that is represented in memory. Now let's continue to the three-dimensional array. So let's see how the three-dimensional array is represented in the memory. So let's say we have a three-dimensional array like this, and the way that it will be represented in the memory is again one-dimensional array. So this means that the first element will be 0 depth, 0 row and 0 column, then 0 depth, 0 row and 1 column, and it continues like this. So as you can see, it starts from first, which means that in the 0 depth and the first row, all elements is located over here. Then in the 0 left depth and the second row is located over here, and it continues like this. So as you can see, regardless of the number of dimensions, the arrays are located contiguously in the memory. So the way that we are expressing it like this, to explain the users that to have a clear picture of different types of array. So hopefully everything is clear about how the arrays are located in the memory. So see you in the next lecture.